we shall admit the students, no, sir?
Yes.
Yeah, please.
Hello, Bindi Heli.
Yes, madam. Radhika, madam.
I didn't get the link.
Good.
Sir, give me 2 minutes. I'll get back to you, sir.
Shall
After
I-
that, you can start. No. Yeah. First, this link has to be sent to all the students, sir. It takes 5 minutes. Sunil, sir,
Yes, ma'am.
please wait.
Yes, yes.
Okay.
Radhika, madam.
Okay.
Radhika.
Wait, sir. Wait, sir. They're putting the link in the WhatsApp group. Sir, mute the YouTube video, sir,
Yes, ma'am.
which is streaming live.
Yeah, muted.
Are you able to see my screen?
Yes, sir. We can see.
Yeah,
Yeah.
sure. I'm ready. Let me know when I start. When can I start?
Yes, sir. We'll tell you when to start, sir.
No problem. We'll wait for 5 minutes because let
Yes,
the
sir.
students
Yeah.
get in.
Just
It
now
is
we
for
have
them.
shared, sir, we have shared the YouTube link with our childrens. So it will take 5 minutes to join.
No, take your own time. Nothing to worry. I can wait. No
Yeah,
problem.
thank you, sir.
They are important to us.
Yes.
ಅಷ್ಟರಲ್ಲಿ ಇದು ಪ್ರಾಜೆಕ್ಟ್ ಆಗುತ್ತೆ ನೋಡಿ ಅಲ್ಲಿ ತುಂಬಾ ಚೆನ್ನಾಗಿ ಆನ್ ಮಾಡ್ಕೊಡಕ್ಕೆ ಇವ್ರು ಬರುತ್ತಾ ನೋಡಿ
Sunil, sir, enable the waiting room, sir.
Okay. Radhika madam.
Yes, sir.
Please.
Students are joining in YouTube.
Please.
We'll wait for another 2 minutes and then start. 70 members have joined already.
Okay.
Yes, sir.
Now,
We can start.
Yeah. 1 second. Please make admit the students, madam.
Yes, sir.
To check the further.
Yeah, sure, sir.
Sir, please, can you switch off the screen share, sir? Sir, please switch off your share screen, sir.
Okay.
Okay, thank you. Shall I start the meeting, sir? Madam?
Yes, sir.
Yes. The meeting of two personalities is like the contact of two chemical substances. If there is any reaction, both are transformed. By Carl Jung. Good morning, one and all. Myself, Sunil Sankananavar, lecturer from Department of Chemistry, MES Kishora Kendra, PU College, Bangalore. I welcome you all for today's webinar being organized by the Science Club and by the Department of Chemistry on liquid crystals, life, science and technology. Now, we will now have the welcome address by Srimati Shantala HK, the Vice Principal, MES Kishora Kendra, PU College, Bangalore. Over to you, madam.
Good morning, everyone. It is my privilege to introduce and extend a warm and cordial welcome to Dr. Ellamagad, Scientist, Center for Nano and Soft Matter Sciences. Our favorite Bharat Ratna Dr. APJ Abdul Kalam said, "Excellence is a continuous process and not an accident." We are indeed proud to have Dr. Ellamagad sir with us this morning, who followed the words of a great person, Dr. Abdul Kalam, and excelled in life. Sir is an eminent scientist. I have a great pleasure in recalling a few of his numerous achievements at this moment. Dr. Ellamagad obtained PhD degree from Karnataka University and carried out postdoctoral research at the Department of Organic Chemistry, IISc Bangalore, and Department of Applied Chemistry, National Chiao Tung University, Taiwan. Ever since 1997, he has been a scientist at the Center for Nano and Soft Matter Sciences, Bangalore. His work focuses on soft matter, nanomaterials, nano-soft composites, and other closely related systems. He has many noteworthy scientific contributions in the field of functional materials, which can be known with his journal research publications numbering over 200 with H index 36 and greater than 3,900 citations. Students in research field, which is of remarkable achievement. To his credit, he has 11 national and international patents, which shows the quality of his research works. He has been the principal investigator for projects sponsored by governmental and private agencies. He has presented over 300 invited talks and written reviews in journals and in textbooks. Further to his cap, he has been the recipient of many awards and fellowships. I'm proud to announce his few of awards and fellowships here, which are: in the year 2000, Japanese government's JST, that is Japan's Science and Technology, and JSPS fellowships in the year 2002 and 2003, which is one of the fellowships given for overseas researchers who have an excellent record of research. Sir also bagged Government of Karnataka's Sir C.V. Raman Young Scientist Award in the year 2005. In the year 2007, he got the Royal Society's London Visiting Fellowship. I am proud to announce that he bagged Materials Research Society of India Medal in the year 2019 from Indian Institute of Science. In the same year, he has been awarded Fellow of Royal Society of Chemistry from Royal Society of Chemistry, London, which is of great recognition of his work. He also won Chemical Research Society of India Medal in the year 2021 from Indian Institute of Science. Sir became executive member of Royal Society of Chemistry, Deccan section. With all these achievements, remarkably, he has been figured among the top 2%, precisely 1.2% scientists in a global list compiled by the prestigious Stanford University, US, which has recently released an authentic list with reference to most cited scientists in various disciplines. This means that he is leading scientist from India and his contributions is well recognized. Student, he is not only a great speaker, but a practical man of action. We therefore look forward to listening to his lecture on the vital subject of science. On behalf of principal, staff, and students, I extend a hearty welcome to you, sir.
Thank you very much. Thank you.
I welcome our beloved principal, Sunita R., and all my colleagues on this occasion. A warm welcome to all my dear students.
Now it is time to begin the session. I request the speaker to take over the session. Sir, please. Sir, you can start the session.
Yeah. Good morning, everybody. Madam Sunita, I am so grateful to you and Shantala Madam for giving me this wonderful opportunity. And also saying a few good words about me. I didn't know that I have achieved so much. Well, at the outset, I would like to express my deep sense of gratitude to all the organizers, especially the principal, vice principal, staff, and students for having given me this wonderful opportunity be among you young scientists. I would like to refer you all students as young scientists. We never know that some of you may win even Nobel Prizes. Who knows? Well, I'm really delighted to be among you. I know MES Kishore Kendra is one of the very popular colleges in Karnataka and perhaps in India. I know MES Kishore Kendra has been giving wonderful students to the society. Well, today I'm going to share with you a topic entitled Liquid Crystals, Science, Life, Science and Technology. I would like to begin my presentation with the statement that, in fact, it is true, without the existence of liquid crystals, none of would have existed on this earth. I shall repeat, without the existence of another state of matter called liquid crystals, none of the living systems would have existed on this earth. I shall substantiate my statement later on. Well, before I proceed with my actual presentation, I would like to say a few words about my center where I'm working as a researcher. Yeah, this was established way back in 1991 by a great physicist called Professor Sivaramakrishnan S. Chandrasekhar. I'm really blessed to be associated with this particular research organization because it is one of the leading organizations in India and in Asia. This is because this particular research organization has been focusing on both science and technology. And so far, we have been able to get 19 international patents, very important patents, as far as the liquid crystal display technology is concerned. I'm really blessed to be associated with this organization for the other reason that this was established or founded by a great professor, S. Chandrasekhar. S. Chandrasekhar, as all of you know, or some of you know, he is a nephew of a Professor C.V. Raman. Means he is a CVR's younger sister's son. You know, another S. Chandrasekhar, who won the Nobel Prize, okay? He's also a nephew of Sir C.V. Raman. Now, on the lighter side, if you look at, if I put a peta on Professor Chandrasekhar, S. Chandrasekhar, our director, founder director, and put a peta on Professor S. Chandrasekhar from USA, you can see all of them, they look identical. I want you to look at their nose. Especially, you can see their nose are identical. You see this, see the feature, and see the feature. I'm really blessed to be associated with this because I had long interactions with a great Professor Chandrasekhar. I think most of you know, or let me have the pleasure of saying, Professor Chandrasekhar was nominated for Nobel Prize for the discovery of discotic liquid crystals for the first time. He was nominated on 3 occasions for the Nobel Prize. I think all of you must understand that nominating a person for a Nobel Prize itself is a great achievement. Professor Chandrasekhar, however, passed away in the year 2004. Otherwise, you would have got the Nobel Prize. Okay, right from the inception of our center, say from 1995, we have been working on soft materials. I'm sure all of you are able to hear me.
Yes, sir.
Yeah, someone should respond.
Yes, sir.
Yeah, fine. You are able to see my screen?
Yes, sir.
Yes, sir.
Properly.
Yes.
So everything is all right?
Yes, sir.
Yeah. Okay, fine. Right from 1995, we have been, that was the year of establishment of this particular research organization. We have been focusing on soft material. In particular, we have been working on liquid crystals, which can be used for display and solar cells. Nowadays, in and out, most of you use many devices, electronic devices. All of them comprise a small panel called liquid crystal display. So your mobile phone, laptop, or television, whatsoever, nowadays, in most of the visual aid, we are using liquid crystal display. And as just now mentioned, Professor Chandrasekhar discovered discotic liquid crystals. Those can be used for the solar cells. I'm sure in the days to come, you have solar cells based on the discovery of discotic liquid crystal by Professor Chandrasekhar long ago, when he was in the Raman Research Institute. We are also focusing our attention on gels. Those can also be used for liquid crystals. Very interestingly, in recent times, we have been working on nanomaterials. What we are trying to do is we are trying to carry out a perfect marriage between nanomaterials and soft. As name itself says, soft means they are very soft materials, whereas nanomaterials are, though they are ultra fine, but they are very, very hard materials. Try to catch me, especially students, try to catch me what I'm trying to say. Nanomaterials, well, they are ultra fine materials, that's all right, but they are very hard materials. They are very, very hard like a stone. At the same time, we have soft materials, but they are very soft. Name itself says they are soft. Now, how can you carry out a perfect marriage between nanomaterials, a hard man with a soft girl? Is very difficult. But however, one can put in efforts using your chemistry knowledge. One can really try to associate nanomaterials with the soft materials so as to create what are known as soft nano composites. Well, soft materials have, for example, liquid crystals. They have n number of interesting characteristics, properties. These properties have been well utilized for the technology as such, but at the same time, without the great function of the soft material, which are nothing but liquid crystal, there are a number of soft materials, but I'm referring in this particular talk, I'm talking about only liquid crystals. So as I said, liquid crystal form the basis of our life. Without these presence of these soft materials within our body, none of us could have existed. It could be unicellular system or bicellular system or tricellular system or tetracellular system. We are multicellular systems. None of us would have existed without the function of soft materials. Well, as I said, soft materials have their, especially liquid crystals, have their own characteristics, and nanomaterials have their own characteristics. Now, imagine two entities which have their own functions. They have n number of extraordinary properties. Nanomaterials have n number of extraordinary properties, and soft materials have n number of properties. How about if you combine them? Now, let me combine soft materials with nanomaterials, not physical association. You can mix two. You take a soft material, say, for example, butter and stone powder. Okay, when you try to mix them, they don't mix because soft is soft, hard is hard. Now, I can, using my chemistry, I can try to take these soft materials and try to associate with nanomaterials. In a sense, I'll be establishing a bond between soft and nanomaterials. So as to realize what are known as soft nanocomposites. Ladies and gentlemen, in the days to come, you have functional materials for many applications wherein nanomaterials are bound to soft materials like liquid crystals. So this is what we have been doing in this center now. To our efforts, we have been able to get some beautiful results in the recent time. If time permits, I shall share. In 1 or 2 minutes, I can share. As far as my, I'm basically a synthetic organic chemist. My research group is focusing on the molecular design, synthesis, and characterization of natural synthon-based, economically feasible, conventional, not conventional functional liquid crystals, nanomaterials, and liquid crystal nanomaterial composites for fundamental research as well as applied science. Under the class of conventional liquid crystals, we have been working on signones and phallotic liquid crystals, and we have been also working on supramolecular and fluorescent discotic materials. This is one of our major research area. We are working on what are known as oligomeric liquid crystals. You take a liquid crystal molecule. Liquid crystals are nothing but the organic or metal-containing organic molecule. You take a liquid crystal molecule, it has one function. Take another molecule which has another function. Let's say that it is it reacts to once it is exposed to UV light or something like that, it has a photoresponsive characteristics. So I can take one molecule, another molecule which has photoresponsiveness, that behavior. If I combine these two, then at the end I'm getting wonderful material capable of showing a number of properties. So like that, we have made dimers, trimers, tetramers, and so on. So this is the area which is being recognized throughout the world. As far as our center is concerned, this work is quite highlighted. I mean, in a sense, everybody recognizes this work. They have realized that, I mean, our concept can be extended to even technology aspect, technological side. Well, we have been also working on banana-shaped molecules. In liquid crystals area, we use rod-like, cigar-like, disc-like, chapati-like, or banana-shaped, something like that, depending upon how molecule look, how they appear. See, for example, rod-like molecule appear like a rod. Therefore, they're called rod-like molecules. If the molecules Professor Chandrasekhar discovered discotic liquid crystals, they exactly look like a plate or chapati. I mean, symmetrical chapati. Okay. And now what I'm showing is banana shape. See, look at the molecule. Molecule appears as if it's a banana. It has a banana. It has gained the banana shape. Therefore, it's called banana shape. It's nothing to do with the banana, but only when you talk about shape anisotropy. I'm sorry. They look like banana. Therefore, they're called banana-shaped liquid crystals. Now, these banana-shaped liquid crystals are quite interesting, though there is no molecular chirality at the core of the molecule, means there is no molecular chirality. Despite that, when they self-organize, they give you what are known as chiral liquid crystal phases. So that is quite interesting. Suppose that if I want to make a device out of chiral liquid crystals, I need not spend much money. I can use these banana-shaped molecules and fabricate a device. In recent times, as I said, we have been also working on what are known as soft nanocomposites. What we are trying to do is we are trying to develop sensors for toxic metal ions, toxic gases, explosive sensors, and detectors. Now, let me spend 1 or 2 minutes here. We know that the whole world is quite affected by the usage of explosives. I think now, in recent times, you heard about, or you must have seen, a huge explosion of ammonium nitrate in one of the countries. I don't want to name it, but in one of the countries, 2 tons of ammonium nitrate was exploded. They stored it for 7 years, and nobody bothered to look at it. It exploded. Now, let me tell you the interesting aspect. In India, we have seen it has come to the notice of scientists that by the government of India that some of the people carry ammonium nitrate in the flight. Imagine some of the persons, you know what kind of persons they are. They carry ammonium nitrate in their bag. When they take a flight, they get into the flight, they take ammonium nitrate, they tell that it is a sugar or it is a prasadam, something like that. They somehow take it inside. Now, it's very difficult to, the ammonium nitrate is exactly like a sugar or a salt. Okay. When you have a sugar or a salt and ammonium nitrate, they look alike, perfectly one. You can't distinguish. Now, what we have done is we have developed reagents, a very simple reagent. Take ammonium nitrate, add our reagent, there will be change in color. Okay, we can also do it by colorimetric. This is called colorimetric method. We can also do by fluorimetric method. So we have developed a reagent that can sense as many as 6 explosives, including RDX, ammonium nitrate, and C20, Cl20, TNT, TNP, like that. So using simple polymers, that is coordination polymers, we have been able to develop what are known as sensors for explosives. They are called high energy materials. All the explosives come under the class of what are known as high energy materials. Now, with this, of course, DRDO also has come up with some reagents, and we also come up with some reagent. Our reagents can be used even wherever you take. For example, if somebody suspects some presence of some ammonium nitrate somewhere in railway station or bus stand or some sensitive place, crowded place, we can go and immediately detect. You don't need anything. Just take small amount of that, okay, and then add reagent. It will limit, or you don't have to even do that. Just fill the sensor, our reagent, chemical sensor, chemical reagent. There will be change in the color, intense change in the color. Therefore, one can detect the presence of explosives. Now, as I just have said, to make it very simple, Let's say that somebody takes ammonium nitrate in the airport, okay? And that gentleman says, you know what kind of persons that those can be. He or she says, okay, it's a sugar. It's a prasadam, I'm taking it home. But how do you believe? So in most of the time, the inspectors, whosoever it is, they believe. But nowadays, they are very strict. This happened some time ago. One of our industrial partner, to demonstrate how bad we are in security aspect, what they did is they took ammonium nitrate, 1 kg of ammonium nitrate in a bag. It doesn't explode unless there is something, there is some kind of a initiation. So you can take it comfortably. I think ammonium nitrate is, I think all of you know, it's used to make this fertilizer. Well, that gentleman, that my industrial partner took it, he said that I'm going to demonstrate it. He took it to the aviation minister, he got into the flight and then got down from the flight, and he was carrying ammonium nitrate and went and discussed, this is what I have done. Nobody could catch me. This is because it looks like a sugar. Okay, now how to test it? That is a big question. So in recent times, what has done is no powder or no sugar-like powder is allowed in the airport. That is what has come out recently. So what I'm trying to say is there should be a way of detecting things without any much effort. Well, if the gentleman says, okay, it's a sugar, test it, let me test it. So we'll be giving you some reagent, immediately take it and test it. We'll be giving a kit, take it out, take that explosive and add a few drops of it, it will sense. I hope you got this, what I'm trying to say. So what I'm trying to say is using simple chemistry knowledge, using simple chemicals and our chemistry knowledge, one can do wonders. Many people think that research is very complicated. No, it's not the case. The best demonstration would be the discovery of Raman effect by great Sir C.V. Raman. I think in 30-40 rupees, he constructed his device and he demonstrated the Raman effect. What I intend to say is, you students should participate. You should take your science career as a prime career and try to think on your own. Nothing is complicated. There are many demonstrations. For instance, Professor C.N.R. Rao. Professor C.N.R. Rao, if you look at his publications, they are quite simple. The simple thinking gives you many interesting results. You need to be extremely simple. You should not make it complicated. So try to think, means you have to think about science, or you have to talk about science logically. If you try to by heart, if you try to put in hard efforts and try to understand, science never gets into your mind. You need to be very simple, try to understand, think logically. As a common man, try to think. So these are the, what I intend to say is, for a good research, you don't have to have, what is called, at least idea. Yes, for the testing purpose, you need equipments. At least for the generation of idea, no computer can do it. You students who are really brilliant, who are really interested in research, should come up with ideas. Having idea, conceiving an idea, then first you should conceive the idea. Yes, I want to do this. Then realize it. So this is stepwise. So this is how Professor C.V. Raman or Sir C.V. Raman or Professor C.N.R. Rao or anybody, Professor Govardhan Mehta, one of the well-known organic chemists, they all have, what they have done is they have done simple experiments, not complicated experiments. Okay, so that's how they have been very successful, and their science, whatever science they do, it reaches to a common man. Okay, we have been also working on composites for electrocatalysis also. What do you mean by electrocatalysis? In the days to come, I think all of you are sure and agree with me that in the days to come, we run out of petrol, diesel, or whatsoever. It can be anything, even charcoal. Soon we are in another 20 years or so, in 2 decades or so, we will run out of petrol, diesel, and other things. Then imagine, without petrol and diesel, how can we run life? So instead of that, in the nature, you have 90% of water. So can we use water? Now, let's say that tomorrow I have a car. Instead of me going to petrol station to put petrol, gasoline, I take out a bucket of water, put it into my car, start the car. How nice it is. So that's how electrocatalysis plays an important role. What we are trying to do, or Professor C.N.R. Rao or any material scientist in these days, what we are trying to do is we are trying to address this concern. Take water molecule and split it. If you split water, it's extremely difficult. Ladies and gentlemen, please note that it is extremely dissociate H2O to H2 and oxygen. The composition, the components are hydrogen and oxygen. Hydrogen mixes with oxygen to give rise to water molecule. But you can't reverse it. Very extremely difficult to reverse. Once you have the water molecule, that is the most stable compound, most stable chemical on this earth. It's extremely difficult to split. Try to split water, almost impossible. Okay, but we scientists are trying to do, all the scientists are trying to do is, what we're trying to do is take water molecule, split it. So you have hydrogen, that's as a source, and oxygen. So when you run a diesel car or petrol car, what happens is that there is a evolution of the, when this petrol gets burned to give energy, along with that you have very toxic gases coming out. That's how in nowadays Delhi what's happening. At least we are blessed, Bangaloreans are blessed, or some other, in any other city if you take, we have lots of problem with the gases produced by the vehicles. And also there are plenty of industry around Delhi and in and around Delhi, therefore there is a problem. Now, can we address this problem? Yes, you can address this problem, provided you avoid using petrol or diesel. Now, other alternative is, as all of you know, or you must have read, water. Take water, put it in your petrol tank, and it will split to give you hydrogen as energy to proceed. It's a source of energy, and the byproduct is oxygen. Now, by running your vehicle, you are releasing the oxygen. So that's how this particular research area is picking up now. Okay, now coming to my topic, I shall take the liberty to talk to you today. All the teachers and researchers have to excuse me because I'm trying to touch some elementary things for the students. I know that MES Kishore Kendra students are quite brilliant, but for the sake of completion of my talk, I would rather touch upon small things, elementary things, and then talk about what I want to talk. So what is matter? So matter is everything around you. Matter is an object that occupies a space and has mass. It can be visible or invisible. Matter is made up of atoms or group of atoms or molecules. Why matter exists in a different form? Well, you have different states of matter. Their properties are different. But why do they occur in different forms? The best answer is, the simple answer I can give as a chemist, as a researcher, is that the correlation between the constituent atoms, the correlation, I shall repeat, the correlation between the atoms or group of atoms or molecule is different. So macroscopic properties, therefore, macroscopic properties are different. All right. Well, right from your school days, today I'm going to speak to you about one of the fascinating aspects of science, that is the existence of liquid crystals. Okay. Now, henceforth, you be attentive. Be attentive. All the students, I request all the students to be very, very attentive, because I'm getting into a technical session. Right from our school days, we have been made aware of the existence of different states of matter: solid, liquid, gas, and plasma. In addition to this, there are 4 different states of matter, which we are aware of very well. In addition to this, there is another state of matter called liquid crystals. Ladies and gentlemen, liquid crystal represent yet another state of matter. As we have solid, liquid, gas, and plasma. Liquid crystal, many people do not know about liquid crystal. Liquid crystal represent yet another state of matter that exists between solid and liquid. Given the very fact that this particular state of matter exists between solid and liquid, it obviously has the properties of both liquids and solids. I shall repeat, liquid crystal, given the fact that liquid crystals exist between solid and liquid state of matter, they show the properties of both and solid. I shall talk about it a little later. So if you take a liquid crystal, in your body, you have n number of liquid crystals. First, you note that in your body, you have n number, your body is full of liquid crystals. Please note that point. I shall come back to that point a little later. Your body, you are a bundle of liquid crystals. You don't have anything other than liquid crystals in your body. Let me proceed and substantiate what I'm saying. Well, in addition to a solid, liquid, and gas, we have another state of matter called liquid crystal that exists between solid and liquid states of matter. In addition to this, there exists another state of matter called Bose-Einstein condensate. This was, it's a low energy form of matter, and we are talking about the order than the solid in that the restrictions occur not only at the molecular level, but on the atomic level. So I think this particular slide is very useful to you, especially it has changed your concept or understanding about the occurrence of different states of matter. I think just before about 10 or 20 minutes ago, you were knowing only about liquid, solid, liquid, gas, and plasma. All the students, I think you should be thankful to all the teachers and principal and staff who have worked hard to bring me here, that I was able to let you know that there exists another state of matter called liquid crystals, and that forms the basis of our life. Not only our life, anybody starts with a single unicellular system, or you can go up to multicellular system. I shall come back to this point little later very strongly. Well, now this slide is very important. You are aware of the three well-known and common states of matter. Now, solid can be, solid upon melting go to a liquid state, and liquid upon evaporation goes to a condensed state. I want all the students to look at how molecules are, especially in terms of the movement, how they are correlated to each other. Now, if you take solid, molecules are static. They are not moving, except for thermal fluctuations, nothing happening. It's rigid. There is rigidity. Their molecules are not moving. But when you go to liquid, look at the molecule. You take a cup of water without botheration what's happening, you gulp the water. But this is what exactly is happening in your water. See, look at the molecules. They are dancing. They tumble in all possible directions. You take any liquid, whether it's a coconut oil, or it could be a diesel, it could be petrol, the molecules will be dancing inside. Unlike solids, suppose if you take a chalk or whatever it is, in the solids, molecules are held tightly. Whereas if you go to liquid, the molecules are dancing. They tumble in all possible directions, 360 degrees rotation. But if you go to gaseous state, molecules are diffused. It's quite easy to understand. Now, when I talk about liquid crystals that should come between here and here, they should have the properties of some properties of solid, some properties of liquid. Well, now solid upon melting, it goes to liquid state. Liquid upon evaporation goes to gaseous state. Now, it can be reversed. You condense, for example, you must have seen while cooking your rice or something, water vaporizes, and if you condense it, you'll get back. When you cool your cooker, the water drops will fall. That is nothing but condensation of water. Water would have gone to steam state, and when you condense it, when you cool your cooker, water will come down until you'll have water back in your cooker. So condensation, then liquid upon freezing goes to a solid state. So solid melting gives you a liquid. Liquid upon evaporation gives you gas. Gas upon condensation gives you a liquid. It can reverse, and liquid upon freezing gives you solid back. So this is what is known as phase transitions. So best example is water. You take ice, start with ice, heat it, it will go to liquid state at the room temperature. When you heat it at about 100 degrees centigrade, it goes to gaseous state, that is steam state you call. But you can come back, okay? Right. Now, they are made up of the solid or liquid or gases. They are made up of tiny particles, atoms or ions or group of atoms. They distinctly differ in their properties. This is the consequence of the nature, the polarity, shape of the particles, their arrangements. See now how in a given solid or liquid or gas, whether the molecules are static or moving, how they are correlating with each other, very important, extremely important. In solid, the correlation is very strong. Here, the correlation is a little bit weak. Here, correlation is not there. Well, now, as all of you know, in order to understand what are liquid crystals technically, ladies and gentlemen, let us try to understand the few properties of a given solid. Solids can be categorized into two classification. One is called isotropic crystals and anisotropic. Solids can be divided into two categories: amorphous and crystals. Crystals are further divided into two classes: anisotropic crystals and isotropic crystals. Now, as far as the liquid crystals are concerned, I shall refer to the crystal which are anisotropic in nature. What are they? Anisotropic means they have a crystallographically distinct axis and interact with light in a manner that is the orientation of the crystalline, that is with respect to the incident light. So, I shall be referring to only the crystals here, especially anisotropic crystals. Doesn't matter. For understanding, please note that whether it's amorphous or crystalline solid, the atoms or molecules or ions are held rigidly. Large intermolecular attractive forces hold them together in a solid. Now I shall talk about anisotropic crystal. Anisotropic crystals or crystals, they have position order, they have orientation order. Position order means molecules are restricted to occupy a specific site in a given lattice. And orientation order means molecules are pointed to in a specific direction. They maintain their shape. Given the fact that they have position order and orientation order, they maintain their shape. They do not flow, cannot be compressed. They show, most interestingly, they show a beautiful phenomenon, what is known as birefringence, or they are birefringent materials. What is birefringent? Birefringence is nothing but double diffraction. What is double diffraction? I think most of you know. Or let me tell what is it. Now, I want all the students to note down three important things as far as the crystals are concerned, especially anisotropic crystals. A given crystal never flows. Don't worry about they have position order, orientation, don't worry about it. Now, I want you to note down, if you have a pen and pencil, note down, just note down there. Anisotropic crystal, or given for that matter, any solid if you take, they never flow. Am I right? Given solid or crystal never flow. But at the same time, they will show what is known as birefringence. So some of the anisotropic crystals, they do not flow, but they show what is known as birefringence. Flow is not there. They maintain their shape. So anisotropic crystals or solids, they do not flow, but they show what is known as double refraction or birefringence. What is double refraction? Double refraction is nothing but the measure of the magnitude, birefringence is nothing but the magnitude of the double refraction. You are all heard about refraction of light. It is the bending of light. Well, when you take a cup of water or take a half glass of water, it should be transparent. You take a glass, then put a pencil. It appears as if pencil has bent. It is not the pencil bent. It is the bending of light. When light travels from a thin air medium to thick water medium, light bends. Therefore, it appears as if the pencil has bent. So this is what we call refraction. It is the bending of light ray when it travels from one transparent medium to another. Change in speed causes the direction of the light ray into change, knowing there is a bending. Well, what is double refraction? Having understood what is refraction, there is bending of light. What is double refraction? It is the bending of or refraction of the light into two different directions when it travels through an anisotropic medium, birefringent medium, such as crystal. It's a result of splitting of incident light into two rays. Well, you take an anisotropic crystal. When an ordinary beam of light is made to pass through anisotropic crystal, the incident light of beam gets split into two. So this is a birefringent material or birefringent crystal. When ordinary beam of light is made to pass through a crystal, the incident beam of light, unlike other crystals, is split into two. One is called ordinary light, other is called extraordinary beam of light. They vary in their velocity within the crystal. Well, such crystal, one of the best example is I can take a calcite crystal. Well, I have to show that the incident beam of light, when it gets into the anisotropic medium, for example, anisotropic crystal, the incident beam of light gets split into two. One is called ordinary beam of light, another is called extraordinary beam of light. Well, here is a demonstration. Calcium carbonate crystal, which is rhombohedrically cleaved, it shows what is known as birefringence phenomenon. Now, if I take a crystal, take a pencil, and put a crystal on that, calcium carbonate crystal on that, ladies and gentlemen, as you can see, you are able to see, you are able to see two images. Now, if I take a glass and put on the top of it, you'll be able to see only one image. Unlike that, if you take anisotropic crystal and put on the, at the back of it a pencil, you will get to see the two images. One image, ladies and gentlemen, originates because of the ordinary light. Ordinary light follows all the optical laws, whereas the extraordinary beam of light doesn't follow all the optical laws. So you get to see two images. Somebody is talking at the background. Please mute. I'm getting disturbed. Hello? Hello?
Yes, sir.
Well, somebody is talking at the back. There's a noise.
We'll check it, sir. We'll check it.
So anisotropic crystal, if you take put it on the pencil, it appears there are two pencils, but it is only an illusion. So one pencil, one image originates because of the ordinary beam of light. Another light originates because of the extraordinary light beam of light. I shall repeat. When you take a pencil, on the top of it, you put an anisotropic crystal, you'll get to see two images. One originates because of the ordinary beam of light, another originates because of the extraordinary beam of light. Now, if I rotate this crystal, interestingly, the image which is originated because of the ordinary beam of light remains stationary, whereas interestingly, the image which is generated out of extraordinary beam of light rotates along with the direction which you rotate. So that is quite interesting. Now, suppose if you come to our lab, I can show you all the crystals here. Means if you go to even Raman Research Institute, they have n number of anisotropic crystals which has been collected by a great Sir C.V. Raman. If you go to RRI or you come to our laboratory, we can show you this phenomenon. So one image remains stationary, that is because of ordinary beam of light, and another rotates with angle which you rotate. So this is known as birefringence. Means, I shall repeat, what is birefringence or what is birefringent object? There are some crystals in the nature itself. When an ordinary beam of light is made to pass through, which is to be transparent, is passed through that anisotropic crystal, what happens is that the incident beam of light, it can be any light, sunlight or tube light, or any light you can take, a candlelight, whatever. So when a candlelight or sunlight or ordinary beam of light or your tube light is made to pass through anisotropic crystal, the incident beam of light gets split into two. One is called ordinary beam of light and extraordinary beam of light. Well, now how to check whether the given crystal is anisotropic or not, or whether it shows birefringence or not? Well, I think all of you are aware of the polarizers. What are polarizers? Let me explain. When an ordinary beam of light is made to pass through, I know that the light propagates in, what is unpolarized light? Unpolarized light, a light wave that has a vibrating in more than one plane is referred to as unpolarized light. So ordinary light, it can be candlelight or tube light or sunlight, whatever it is, it's called unpolarized light. When such an ordinary beam of light is made to pass through what are known as polarizers, the vibration of light gets confined to a single plane. I'm talking about only the electrical vector. I'm not talking about the magnetic vector here. Electrical vector is important as far as liquid crystals are concerned. So when an ordinary beam of light is made to pass through a polarizer, let's say that is a horizontal polarizer, the vibration of light gets confined to a single plane in a horizontal manner. This is called horizontal state. Now, if I take another polarizer, okay, and if it is horizontal, you get a horizontal state. Okay, as shown here, a candlelight is made to pass through a vertical polarizer, you get a vertical state. All right. Now, if you take the same vertical polarizer, rotate it by 90 degrees, so you'll get a horizontal polarizer. When an ordinary beam of light is made to pass through horizontal polarizer, you get to see the horizontal state. So, using polarizer, vertical polarizer, you can get vertical state of the light. This light is called plane polarized light. It can have plane polarized. We can get two types of plane polarized light. One can have it in a vertical state or horizontal state. I shall repeat. When an ordinary beam of light is made to pass through vertical polarizer, you get a plane polarized light that is that's existing in a vertical state. When you take the same polarizer, vertical polarizer, rotate it by 90 degrees and make a light to pass through it, you get horizontal state. Well, how about using two polarizer, one vertical, another horizontal? Now, as I shown here, when vertical polarizer or horizontal polarizer are not crossed, then light passes through. As I shown here, here you have one horizontal polarizer, another horizontal polarizer. When the states, okay, when their vibrating states are identical, then you will get to see that color is coming out. Interestingly, I think many of you know that when vertical polarizer is made to fall on horizontal polarizer or they are crossed, then light does not come out. Yeah, as you can see here, when you take a horizontal polarizer, put on the vertical polarizer, cross them, means the two cross polarizer, means between the two cross polarizer, light would not emerge. So as I shown here, it's a single polarizer, two polarizers with the same orientation, lights come out still, but two polarizers in opposite direction, means a vertical polarizer is put on the horizontal polarizer, so light does not come out. Okay, I think you know what is happening here. Don't worry about that. Now, I want you, student, to think about it. Now, imagine that you are talking to me. Imagine all the students who are really come forward to attend my talk. Imagine you have polarizers, cross polarizer, wherein light is not coming out. How can I make light to come out? Imagine, just imagine. Now, can you think of putting an anisotropic crystal? Yes. Now, suppose if I take a glass, just a simple glass, or air or water, put between the two cross polarizer, light would not come out. Okay, I'll come back to that point a little later. But these anisotropic crystals have the ability to generate another beam, extraordinary beam of light. Okay, if the materials are normal, wherein the incident beam of light gets into that, comes out as ordinary beam of light, you can't do anything. But if you put anisotropic crystal between the two cross polarizer, given the very fact that these anisotropic crystals have the ability to generate another beam of light, light would come out. So now, if you take anisotropic crystal, okay, put between the two cross polarizer, ladies and gentlemen, the light would emerge. You can see beautiful colors because it is because of the interference of the extraordinary beam of light and ordinary beam of light. So here, the point to be noted is that when you take anisotropic crystal, as I said, how do you test a given system or a molecule or a given material is anisotropic or not? Ladies and gentlemen, there are so many plastics you use in your day-to-day life. All the plastics which are transparent are birefringent. Now, suppose if I take two polarizers, you can see the cross polarizer. If I put my what is called tiffin box, nowadays when you go to hotels, you get to you will get the your whatever it is. What is palya or something like that. What is it called? Curry you will get in a box. This is the lid of the box. Now, if I put between the cross polarizer, ladies and gentlemen, you can see the beautiful color. Previously, when there is nothing, the air is there. Air is not anisotropic, okay? Air is isotropic. So light is not coming out. But if I put between the two cross polarizer and an anisotropic medium, say, for example, solid or a plastic or anisotropic crystal, light would emerge because they have the ability to generate extraordinary beam of light. So whatever you are seeing is nothing but due to the generation of extraordinary beam of light. Okay, but I want you to understand very important point too. I want you to note down a very important point is that when an anisotropic crystal is placed between the two cross polarizer, it let the light to out. It shows light. Okay, it allows the light to pass through, means light comes out because of the extraordinary beam of light. But at the same time, there is no mobility here. I shall repeat. You are taking an anisotropic crystal, all right, putting between the two cross polarizer, light is coming out, all right. Light is coming out, fine. Because of the generation of the extraordinary beam of light, all right. But at the same time, please note that there is no mobility here. They are not moving, okay? Solids between the two cross polarizer, yes, there is a light, but there is no polarization, but there is no mobility. They are not moving, okay? Now, I shall talk about liquids and then try to define what are liquid crystals technically. Now, molecules are held loosely in liquids. Molecules or ion or group of atoms whatsoever. They are held loosely and they diffuse randomly, okay? This happens because of the no positional order, no orientation order. They do not maintain their shape. They flow, cannot be compressed, not birefringent. Try to understand the difference between the solid, the correlation to the solid, the correlation of the molecules or atoms or group of atoms in solids. Now, in solids, as I demonstrated to you, in solids, there is an orientation order, there is a position order, there is a birefringence, no flow. This is exactly opposite in liquids. Molecules held loosely because there is no position order, no orientation order, no birefringence, and no fluid. They are fluid. Solids, they show birefringence because of the presence of some order present in the system. I shall repeat: crystals, they do not flow. Crystals, they do not flow. But when you put between the two cross polarizer, light would emerge, but there is no mobility. All right. But when you talk about liquid crystal, okay, in solids or anisotropic crystals, the birefringence happens because of the special arrangement of the molecules which are held rigidly. That rigidity or order gives you birefringence. Now, obviously, this birefringence cannot be seen in liquids because there is no positional order, there is no orientation order, no birefringence. Okay. In solids, please understand, solids, they do not flow. Solids do not flow, but at the same time, they show birefringence. I shall repeat. Solids, they do not flow, but they show what is known as birefringence. Birefringence is a consequence of the special or rigid arrangement of the molecule present in a solid. On the other hand, contrary to that, liquids flow. Solids do not flow, show birefringence. Liquids flow, but there is no birefringence. I shall repeat. Solids, no flow, birefringence. Liquids, flow, no birefringence. I got you. I hope you have got my point. This happens because how molecules are inside. In solids, molecules are static. There's order. Therefore, birefringence comes out. So it means that when I talk about order, there should not be flow. Or when I talk about fluidity or mobility, there should not be birefringence. I hope you are getting my point. When I talk about liquids, since there is the molecules flow, there is a fluidity, birefringence will not come. Under the sun, we have n number of anisotropic crystals. Their interesting properties are they do not flow, but when you put between the two cross polarizer, they show what is known as birefringence, but there is no flow. But when you talk about under sun, we have n number of liquids. It can be diesel, petrol, coconut oil, whatsoever. You take any number of any liquid present on this earth and try to put between the two cross polarizer, ladies and gentlemen, you don't get to see anything here because they are anisotropic, but they are fluid. Here, solid, light comes out, all right, but there is no fluidity. But here, in the case of liquid, there is no light, but there is a fluidity. Solids, birefringence, no flow. Liquids, no birefringence, but there is a flow. Now, when I talk about liquid crystals, I think you are already getting my point. When I talk about liquid crystal should show the properties of both. That is, they should flow like liquids. They should flow like liquids. At the same time, they should show birefringence. Ladies and gentlemen, just now I told you, whenever you talk about birefringence, there has to be order. If there is no order, there cannot be birefringence. But I think this cosmos energy has created a wonderful state of matter that shows the properties of both. In fact, if you think carefully, then it appears that there are contradicting property. It's not the case. There is a science behind it. What is it? So liquid crystals, which exist between solids and liquid states of matter, they flow like liquids. They flow like liquids. At the same time, they show birefringence. Okay? Here is a slide which will tell you the story. So liquid crystals are the intermediate state between that of a solid and liquid. I want you to look at how the molecules are correlated, whether they are moving or not moving. If they are moving, how they are moving. Now, solids, orientation order, position order, birefringence, no flow. All right, you already know about it. Then, no position order, no orientation order, not birefringent, fluid and viscous. All right, you have understood. So in given liquid, molecules tumble in all possible directions. They tumble really. Whereas if you take solid, molecules do not tumble. They are static, okay? Because they have orientation order and position order. Whereas in liquids, there is nothing, no position order, no orientation order. So molecules tumble in all possible directions. Ladies and gentlemen, I would like to draw your attention what's exactly happening in liquid crystals. Given the very fact that it exists between the solid and liquid, it has a property, bit of solid property, a bit of liquid property. Like as you see here, molecules are not static. Molecules are not static. They are moving here and there, but with some order. They are not moving like in liquid. So you can see none of the molecule is tumbling. They're moving, all right. Up and down, they're moving. They are not static. They are moving, but with some order. Okay, let me give one example in our common life. Now, suppose that you go to Majestic or any bus stand or railway station, you consider individual person as a liquid crystal molecule, how they are. I mean, when you go to a market or when you go to a place wherein people are scattered, they are moving here and there, here and there. Someone is trying to catch a train, someone is trying to catch an auto, or someone is trying to bus, or someone is trying to do something, someone trying to go to hotel. So people are scattered. So there, that is a representation of a liquid. Now, when you come to any procession, okay, it could be any procession or jatra, whatever you want to say. So when you talk about a procession, I don't know how to tell it. Procession means in Kannada, I don't know. A procession, if you take, so something will be carried, palaki or something like that. I don't know how to say it. But when you go to a procession or you take military parade, people are moving, but with some order. In a procession, people will go in one direction, okay, forward direction. People are scattered. I mean, they are scattered, but with some order. So that is a representation of liquid. It is a military parade, or if you take any person, I mean, the mass which is present in the procession, it represents liquid crystals. Okay, okay. Now, as you see here, liquid crystals. So far, about over 50 different liquid crystals have been discovered, and their existence has been demonstrated. As far as the Indians are concerned, we have contributed more than about 15 different different liquid crystals. We have contributed, we have discovered. As I just now said, as far as the liquid crystals are concerned, Indian scientists contribution is significant, quite significant, especially in terms of the discovery of discotic liquid crystals. Now, if you take liquid crystal, it has an orientation order, means if you want to call a state of matter as a liquid crystal, the necessary condition is that all the liquid crystals should have what is known as orientation order. If you talk about liquid crystal, they should possess what is known as orientation order. In addition to orientation order, some of the liquid crystals do have position order in one or two directions, and therefore they show what is known as birefringence. Well, at the same time, they flow and they are viscous. The first three properties are coming from solid. The fluidity and viscosity is coming from the liquid. So therefore, ladies and gentlemen, liquid crystals represent yet another state of matter. They flow like liquids. At the same time, they exhibit what is known as double refraction or birefringence. When you talk about birefringence, there should not be fluidity. Or when you talk about a fluidity, there should not be birefringence. As I just now mentioned, Cosmos energy, I believe in Cosmos energy, has created wonderful state of matter, that being liquid crystal. It flows like liquids. At the same time, it shows what is known as birefringence. Now, in the next slide, I will show you a liquid crystal. This is a liquid crystal, okay? Now it is in the liquid crystal state. Now I am seeing it between the two cross polarizer, okay? It is called, I'm sorry, excuse me. So this is pneumatic liquid crystals put between the two cross polarizer, all right? So this is a liquid crystal phase that is being used in your LCD. So in your liquid crystal display, whether it can be of your mobile phone, or you can be laptop computer, or you can have on it in your television, all of them are made up of what is known as pneumatic liquid crystals. Now, suppose that if you touch your laptop or computer, you feel that something is moving, isn't it? You take your laptop and press it a little bit, you feel as if something is moving. Okay, same thing I'm showing you here. So this is liquid crystal state, pneumatic liquid crystal state, which is being used in all the technology. So this is being put between the two cross polarizer. Okay, so therefore you can see the fluidity at the same time its color. Now, if I take this liquid crystal, it's a liquid crystal one state. It's coming from the solid. The solid has been melted. You are into the liquid crystal. So liquid crystal, now you are heating it further. It goes to liquid state. Now, I want you to really understand that there are n number of organic molecules on the earth, or you synthesize at lab. Suppose that if you take benzoic acid, when you heat it at 122 degrees centigrade, when you supply heat, I mean, if the temperature is to 122 degrees centigrade from room temperature, at room temperature, benzoic acid is solid. Now, if you heat it up to 122 degrees centigrade or 123 degrees centigrade, it will go to liquid state. Molecule is the same, but it loses its orientation order and position order. Therefore, it goes to liquid. The solid, upon heating, going to liquid is well known. But there are a number of molecules. There are a number of molecules. They are very interesting molecules. They are called liquid crystals. What they do is, when they, to begin with, they are solid. When you heat, they, instead of straight away going to liquid state, they pass through intermediate state, what is known as liquid crystal state. Now, if you check them up between the two cross polarizer, solid should show birefringence, but no mobility. But when you come to liquid crystals, you should be able to see both. That being, those being liquid. When you see liquid crystals between the two cross polarizer, you should be able to see the fluidity. You should be able to see the fluidity at the same time color. Okay. When you go to liquid, there is no color, but there will be fluidity. I shall repeat. Start with solid. Now you imagine you are taking a solid, putting it between the two cross polarizer. You would definitely see the color because that's anisotropic. But there is no mobility. When you come to liquid crystal, what should happen? You should be able to see. You should be able to see the color because of the emergence of the extraordinary beam of light and interference of the ordinary extraordinary beam of light. You should be able to see beautiful pattern, birefringence pattern or textural pattern, which is moving. But once you heat it, you should be able to see, when you go to liquid state, you will not see any color, but there is a mobility. Solid, no flow, there's a color. Liquid, fluidity is there, no color. But if you take liquid crystals in between, they show color, they show birefringence, at the same time they flow. That's what you will see here. So when I'm heating it, transition from a pneumatic phase to liquid phase, what should happen? Now it should move. Okay, and when you go to liquid state, you should not see any color. So that's what I'm doing now. You can see that. Yeah, you can see. Yeah, this is liquid crystal state. Yeah, now it is going to liquid state. Okay, so now what state you are seeing is liquid. So liquid between the two cross polarizer, they look dark, but there is a mobility because it doesn't generate extraordinary beam of light. I shall do it again for you. You can see now it is in the between the two cross polarizer, and I'm heating it. What's happening? Yes, it's moving. Yeah, when it goes to liquid state, it disappears totally. So it means that liquid crystals, which represents fourth state of matter, they show birefringence as well as fluidity. This is called chiral liquid crystal. You can see this also. So now it is going to see it as if the paint is flowing. Now this is liquid between the two cross polarizer. You take any liquid, for example, water, it doesn't, water flows, but there's not any birefringence. But if you take chiral liquid crystal, you can see this beautiful color. This is because liquid crystals have the ability to generate extraordinary beam of light and they flow. In essence, I intended to say that liquid crystals, they flow. That's a property of liquid crystal, liquid. They are birefringent. There's a property of crystal. They're optically anisotropic. In other words, you can call liquid crystals as orientation or they possess orientation order. Orientation order necessarily and position order. I shall repeat: liquid crystals, they flow like liquids. They show birefringence. They're optically anisotropic. They possess orientation order. It's a must. They should have position or orientation order, and some of them additionally may have position order. Right. All right. Well, now so far I've been able to tell you the technical aspect of liquid crystals. Now I shall talk about in about 5-10 minutes. I shall talk about in water. I said that our life is basis. All the living systems have evolved because of the evolution of liquid crystals. Means you take any living system, whether it could be unicellular, bicellular, tricellular, multicellular, whatsoever. We are all multicellular systems. We are all made up of liquid crystals. I shall demonstrate now. Well, liquid crystals is a unique state of matter. As I said, it's the fourth state of matter. The term liquid crystals was coined in 1888 by Otto Lehmann, a German physicist. In a brief form, you can call liquid crystal as ordered fluids or birefringent liquids. As I said previously, there are n number of liquid crystals on the earth, ladies and gentlemen, especially students. Please note, there are n number of liquids on the earth. None of the liquids which flow, all the liquids flow, but they do not show birefringence. Cosmos energy has created liquid crystal state. It flows like liquids, at the same time it shows birefringence. So liquid crystals are generally formed by this, spontaneous self-assembly of some special organic or metal containing organic compounds. Okay, I shall repeat. Liquid crystals are generated in your body. Even in your body, liquid crystals are generated, okay, as a consequence of the self-assembly of some special organic compounds. So you are composed of the self-assembly structures. They are nothing but liquid crystals. So they are this called pleiotropic liquid crystals. So you are composed of pleiotropic liquid crystals. You are full of pleiotropic liquid crystals. And there is one more class of liquid crystals. This is called thermotropic liquid crystals. It is pleiotropic. This is thermotropic. So pleiotropic liquid crystals are formed by the action of water on amplifiers like soaps and detergents. In your system, this kind of molecules are. I shall come back to that point a little later. And thermotropic liquid crystals, so all the devices, whether it's a LCD or mobile phone, whatsoever, you have small panel, all of them are made up of molecules like this. So pleiotropic liquid crystal is something to do with our life, not something to do with our life. It is the essence. They form the fundamental aspects of our life, and thermotropic liquid crystals are into the technology. Okay. Science of liquid crystal is a multidisciplinary one. Records concepts and techniques from the chemistry, material science, solid state physics, and so on, and goes up to biophysics. However, the main contributors to the science of liquid crystals, or science or technology of liquid crystals, are synthetic material chemists like me, organic chemists, who undertake the molecular engineering and synthesis, physicists who carry out the phase characterization and extend them to applications, and engineers, electronic and chemical engineers. So it's a combination of whatever the technology you see as of now, whether it could be it your mobile phone or laptop or whatsoever, you use LCD, they have emerged out of the continuous efforts by chemists, physicists, and engineers. Well, Unlike other states of matter, liquid crystal state of matter is most soft and delicate state of matter. It's extremely sensitive to the external stimuli like light, sound, temperature, pressure, electrical field, magnetic field, and surface angle. Can you explain, please? I'll close the door. 1 minute, please. With your permission, can I have a cup of water?
Yeah, sure.
Okay, I'm back. So liquid crystals are known to be the most soft and delicate state of matter. This is a fourth state of matter, but unlike other states of matter, be it solid or liquid or gas, whatsoever, unlike them, they are extremely sensitive. Light, sound, temperature, pressure, electrical field, magnetic field, or surface anchoring condition. For example, the best example would be you take your mobile phone. When you take your mobile phone and go out in the hot sun, you will not be able to see the images properly because the liquid crystal which is there, now it's going towards liquid state. So therefore, people say to you, mobile phones should not be exposed to sun for a longer period of time. It will go bad very soon. So it is because of the fact that when you take your mobile, take outside your room, when you expose it to the hot sun, especially noon sun, the molecules which are there, they are organic molecules. They are in the liquid crystal state, nematic state. They now go to liquid state. Therefore, you will not be able to see. So in LCDs, you are able to see the image because liquid crystals are able to get you two kinds of images. One image is dark, another is bright. So the combination of dark and bright, which is addressed by which is optimal by application of electrical field. So you are generating in your liquid crystal display, you are generating two states, one dark and bright. So dark and bright color put together, the combination of dark state, bright state, color put together, you will form images in your display. I shall repeat, in your liquid crystal display, you have two types of images, one dark state, another is a bright state, and to that color is being added. So the combination of dark and bright state put together, you'll get the images. Okay, fine. So liquid crystals are extremely sensitive to the light, sound, temperature. Now, let me take our own example. Now, suppose that if you are in an AC room, how you feel? You will be very comfortable, right? But at the same time, if you go outside, say hot sun, how do you feel? So the huge difference. Okay, when you are when you are not exposed to heat, okay, you are comfortable. Means you are in the perfect. Your body, the components of our body are liquid crystal. They are in perfect liquid crystal state. But when you try to go outside, they try to melt. Okay, we have, of course, in our body is such that until we have the recovery ability. All our organs are, basically our cells have the ability to come back. So what I'm trying to say is, you are representing, your body represents liquid crystals. You are a bundle of liquid crystals. I'll come back to that point. You are a bundle of liquid crystals. When you try to go outside, okay, you feel the difference in your mood or comfort. Okay, so this is because in your body you have a number of liquid crystals. If they are in liquid crystals, no problem. But when you try to expose you to hot sun or a temperature above 45 degrees, you will be very uncomfortable because there is the liquid crystal structure at your cellular system is disturbed. Okay. Although they are extremely soft and delicate states of matter, they are vital, promising, and useful media for the living systems and nature. It's a hardly exaggeration to say that in the chemistry of living systems, liquid crystal behavior is as important as the carbon bond. As I said, living things could not have evolved without the occurrence of liquid crystals. I shall repeat this one, which is very, very important. Living things could not have evolved without the occurrence of liquid crystals. you can be very healthy. The present situation is already demonstrated that is a pandemic situation, COVID-19 situation. This very much to do with your liquid crystals. Okay, liquid crystals are saving you. I shall come back to that point if time permits. Okay, life and life process are critically based on liquid crystals. That is, liquid crystal behavior occurs. Note down, please. Liquid crystal behavior occurs in DNA, proteins, tissues, and cell membranes. Now, you said that you are made up of about 60 to 70% water. Where this water is? This water is within the cell and outside the cell. Now, let me talk about cell membrane. See, now I'm coming to a very important aspect. I have been telling you that we are all made up of liquid crystals, how they are present in the body. I'm trying to cover that aspect. We all know that we are considered of tiny particles or tiny living systems. They're called cells or plasmon and cells. So cell is generally covered by what is known as cell membrane. I shall come back to that point a little later. Okay, cell membranes, you are all made up of cell. Okay, cell, this is a constituent of cell. This cover is called cell membrane or plasma membranes. Humans have about 100 trillion cell, and it has a particular weight which can be noted there. It has, we have about 10 to the power 14 number of cells. Its size is about 10 microgram. It has a mass of of the order of 1. So now we have a cell predominantly consists of water. Okay, within the cell there is a water. Outside side there is a water. Water in the body, which is present either within or outside. Water within the body, the baby have about 78% of water. When it grows old by 1 year, the water drops down by 13%. Okay, when you grow old like me, you have about 60% of water. Ladies and gentlemen, you can see, you can infer from this something. What is aging? As far as the science, as far as I am concerned, as a scientist, I would like to put aging in this fashion. What do you mean by aging? As far as I am concerned, aging is nothing but continuous loss of water. So when you grow old, the water escapes from your body. When you are just born, you have about 78% of water. When you grow old, it comes down by 65%. It's proved, and of course there are scientific proofs for this. When you are adult, you have 60%. When you are young, you have 78% of water. It means that I think I should tell about this. Your cell plasma membrane, the cell wall is a perfect liquid crystal. Okay, so your cell wall, which is a lipid bilayer structure, it has two-dimensional structure. Therefore, it's called two-dimensional fluid matrix. Cell membrane or plasma membrane is made up of this this lipid bilayer. So this lipid bilayer is liquid crystal. Means at some point in time it acts as a liquid, at some point in time it acts as a solid. So cell membranes are lyotropic liquid crystals formed by the self-assembly of phospholipids as shown here. So it's alpha lamellar structure. It exists in our system. Well, what happens when you grow old? When you are born, your cell membrane is a perfect liquid crystal because you have a 78% of water. When you grow old, what happens is that when water evaporates within the cell and outside the cell, when you lose water by 13%, then your plasma membrane or your cell membrane, now it is going from, please note, it's going from liquid crystal state to solid state. So it is nothing but your body, which is full of liquid crystals. Now, when you become old, when you cross a day or a minute or seconds, what's happening is there is transformation of this cell membrane, which is in the plasma state. Now, slowly it is going towards crystal state. That's how we grow old. Okay. So whenever a young person has an injury or something like that, the recovery rate is very fast because you're at the cellular level, means your cell membranes are in perfect liquid crystals. Okay. If you are able to maintain the liquid crystallinity of your cell membrane, you remain very, very healthy. I shall repeat. If you are able to, by some means, if you are able to maintain the liquid crystallinity, although you are growing old, all right, water escapes, but you find a method, the way by which you are able to withhold the water within the cell and outside the cell, so as to maintain the liquid crystallinity of your cell membrane, you remain young. Therefore, ladies and gentlemen, when you go to a doctor, or when you talk to an elderly person, or when you talk to a saint or your grandparents, they ask you, they advise you to drink water. That is the reason. Well, once you are born, you cannot survive for a long time. You have to die, but you can die. We can go towards death very slowly. Those who have the habit of drinking water early in the morning, especially, the moment you get up, about 1 liter of water, if you lukewarm, put half lemon and maybe a bit jaggery or honey, drink, even brushing teeth, just get up, go to kitchen, warm water. It should not be very hot. It should be just warm, okay? And then put half lemon and then jaggery. I think many of you are practicing. Put jaggery, put honey. Please note that addition of jaggery or honey is important because you have to maintain pH. Because many people do not, they react very violently. Their body react very violently to lemon because it's quite acidic. So in a sense, not acidic. In terms of chemistry, it's different. I'll talk about it a little later if time permits. So when you talk about lemon, some people react very violently, and it will. The moment you try to, when you get up, you try to drink lemon water. Plain lemon water, it doesn't look. You feel very uncomfortable. So addition of jaggery or honey is important. So just gulp 1 liter of water and do rest of things. Okay, and then over the days, drink about 2 to 3 liters of water. Sip by sip, sip by sip, sip by sip. Early morning, getting 1 liter of water, it will wet. Please note, early in the morning, if you have a habit of drinking water, it will not only wet. It will not only wet your cell membrane or plasma membrane to put it back to the liquid crystalline state. Well, we have, as I said, our body has a great mechanism. You can put back. What is it? You have to address the plasma membrane problem. Means you have to drink lots of water, keep it in liquid state. That's the only how you can remain healthy. There's only mantra you know. So if you have the habit of drinking water, wet your plasma membrane, you can remain very healthy. Please note, ladies and gentlemen. Suppose if you don't drink water, you will be landing into problem. Okay? In a sense, some people, survive, they survive. But one of the best example I would give, I had an opportunity to talk to a great saint, Sri Shivakumara Swami of Tumkur, who recently deceased, quite unfortunately deceased. I had many occasions to talk to him. I especially talked to him in the context of my research. When I spoke to him, he said, water is a source of his energy or his source of living. Okay, that's the cause he lived. He said, over the day, he used to drink about 3 to 4 liters of water. Ladies and gentlemen, without any problem, he lived at least 105 years. That tells you that the water, when you take anybody, any saint or anybody, if you talk to a healthy person, like now Professor C.N.R. Rao, he has been so healthy. You take any senior person like Professor Mehta or whatsoever, you take any senior person in our country, any senior scientist, they know how to live, how to take care of themselves. They drink plenty of water. That's why they remain very healthy. Till today, they are so healthy. It's because of the water. So it means that if you have the habit of drinking water, you are wetting. When you get early in the morning, drink water, you are wetting your plasma membrane. And over the day, you should keep wetting your plasma membrane. That's all, ladies and gentlemen. That's all I wanted to say, ladies and gentlemen. In a sense, if you have the habit of drinking water, you remain healthy. So when you go from, say, 1 year, when you are born, you are like this. When you become 1 year old, you all kinds of nonsense starts. You feel very anxious or whatsoever. When you cross, I almost last picture is mine. I'm quite, now I'm an aged person. So I have lost all my water within the plasma membrane, outside the plasma membrane. So my face shape goes like this from here to there, simply because we rule. When we are young, we are quite, attractive, and you please to, I mean, you will be very attractive. But once you become old, you see how your face becomes. It's simply because your this is very simple, very simple, extremely simple. If your plasma membranes are tending towards crystalline state, death is nothing but your plasma membranes are going to crystal state. So therefore, ladies and gentlemen, my dear students, or all my colleagues who are there, please note that drinking water is extremely important. Okay, so I think I'm running out of time. Can I take another 2 or 3 minutes?
Yes, sir. Sure.
I mean, am I permitted or so?
Yes, sir. You are permitted, sir.
So thank you so much. Very kind of you. So the cell, which acts as at some point in time, it acts as a liquid. At some point in time, acts as a solid, perfect conductor. So cell division happens because the cell membrane is liquid. I mean, it has a fluidity. The cell division takes place because it has a fluid nature. The plasma membrane has a fluid nature. Now, this is one of the experiments carried out in UK by one of my friends, Dr. Pitro. He has shown that the cell membrane, your cell wall, so-called cell wall or plasma membrane or cell wall, it acts as a liquid crystal. It is a liquid crystal, means at some point in time, it acts as a liquid. At some point in time, it acts as a solid, in the sense, soft solid. In a sense, it flows like liquid. At the same time, it shows birefringence. At the same time, it conducts electricity like that of those of metals. You can see an erythrose red cell is grabbed at the opposite end by a pair of colloidal particles held in optical traps. Ladies and gentlemen, this is the cell wall. You can see that. So cell wall can be stretched. Okay. So this is possible only when you wet your cell membrane. The significance of water being you have to wet. You have to wet over the day when you do a lot of activities. Now I'm talking to you. I know that many parts of my my organs, they would have lost water. When I'm talking to you, I throw out. Now you are talking about pandemic situation, how this coronavirus 19 is spreading. When you talk, when you cough, or when you loudly speak, or when you sing, you are throwing out the moisture droplets. Okay, these droplets contain the plasma membrane. These droplets contain. As you know, this COVID-19 is a very tricky situation. I mean, very what you call a very intriguing situation, because there are persons, they are asymptomatic, but they carry the germs, they carry the virus, COVID-19 virus. They look perfectly healthy, but they carry. But when such people talk to you, or when they are around you, when he or she talks, they throw out these small droplets of water, okay, or saliva. It is saliva, it will be thrown out. So they contain this virus, COVID-19 virus. They enter your body, as simple as that. So you are get infected. If your body is strong, if you have the habit of drinking water, let me tell you, if you drink, no, that's what people say, isn't it? Now you are supposed to drink lots of water because you are keeping your cell membrane perfect liquid crystal state. Okay, so that time it's not so easy for the virus to come and get inserted. This is lock and key. Okay, it takes a long time. Again, if I go on talking about that, let's not talk about it. So that's simply, if you drink lots of water, wet your body, keep wetting your plasma membrane. It's not so easy that a virus can come and attack your cell wall. Okay. That is also fatty layer. Outside this fatty layer, your cell membrane also has a fatty layer. So there's a good combination. This is a lock and key mechanism. Okay. But if you have if you wet your cell membranes, it's not so easy. Okay. So therefore, if you drink good amount of water, there's unlikely that you'll get infected. Okay. Washing hand with the soap, water, or sanitizing your hand with alcohol, that's another aspect. But first and foremost, I want you to drink good amount of water. Especially given this situation, you have to drink. Although you are at home, doesn't matter whether you are at home. Especially the teachers who teach a long duration, they should drink more than 4 liters of water. Because when you give 1 hour of a lecture, trust me, you would have lost about 150 to 200 ml of water. Maybe it's on the exaggeration side, but still you'll be losing lots of water. I intend to say that. No one knows how. I mean, suppose now I'm a person who speak very loudly, so I would lose more water than you, other one who speak very softly. So it all depends on. But essentially, what I'm trying to say is the persons, my colleagues who teach to students, they should drink plenty of water. I mean, extra amount of water, say 1.5 liters of extra, because you tend to speak. Okay, the one who are in teaching profession, they should drink lots of water. Overall, what I intend to say is that drinking water is a very good habit. Okay, now I think all of you know that each and every part of our body is controlled by brain. This happens because of what is known as neurotransmission. Neurotransmission means the neurons are generated in your brain and they're passed on to the particular organ. Suppose that if I want to lift my hand, I cannot just lift it without the order by my brain. Now I put my requisition to my brain. I want to lift my hand. That will pass on the message to a particular organ. I'll be able to lift. So there is an order from brain to your particular organ. Say my hand, I will start writing, and I start speaking. This happens because of what is known as neurotransmission. Okay. Basically, if you look at carefully, what does it mean? Your particular organ is made up of tissues. Okay. In turn, you can go back to your cell. So cell wall being liquid crystals, it receives the signal. Signal means in the form of small, these are called electrical pulses. So when electrical pulses are passed on from the brain to cell, a particular organ, in turn, cell plasma membrane, the phenomenon happens. Whatever you want to do, you'll be able to do. It means that your cell membrane act like a conductor. Okay. So what I intend to say is your cell membrane or plasma membrane, which you have n number, 10 to the 40 number of cell membranes you have in your body, all of them are necessarily liquid crystals. They are called iotropic liquid crystals. They flow like liquids. They show birefringence. At the same time, they conduct electricity. So it's because of the properties of liquid crystals, ladies and gentlemen, we are all living. All right. So if you take images, this is how, whether you're sleeping or awake. So this is what happens. I mean, there's a continuous message or continuous order or whatever you want to say. So there is a continuous communication between different parts of your body. Suppose that if you are sleeping, there is a mosquito and comes and sits still, without your notice, you will be able to, take it off. Okay. Or if there is, in these days in Bangalore, since 2-3 days, it's quite chilled. So you protect yourself by putting sweater or something like that. When you're sleeping, you will obviously cover your entire body nicely. It's all because the brain tells you that, okay, there is a, body is not able to cope up, please do something. So this communication happens because of the liquid crystal nature. So this I shall not talk about. There are so many other things in the nature which use liquid crystals. In essence, I intended to say that liquid crystal form an important part of our life. So this is the last 1 or 2 minutes I would take. In our day-to-day life, we use what are known as soaps and detergents or liquid soap. In terms of organic chemistry, we call these molecules amphiphils or soaps and detergents. When soaps and detergents come in contact, it's very, very important. I wanted to tell about this because of the present situation. Why are we scientists or technologists or doctors are asking you to wash your hands properly? Is because of this reason. I shall come to that point later. Now, amphiphils, when water comes in contact with soap or detergent, you generate liquid crystals. Or when you take about 30 grams of your soap powder, put in 100 ml of water, you generate liquid crystals. Okay. So when you take bath without your notice, okay, when you take bath, you get into the bathroom and wet your body and start rolling soap cake on your body or put shampoo. Have you noticed the generation of white thin film on your body? Yes, that white thin film is nothing but liquid crystal. Okay, it has a 4 complicated structure. So this is what it is. Okay, when your soap, when you try to roll on your body, the soap or the amplifiers come in contact with water. Ladies and gentlemen, you are generating liquid crystal structure number 1. Further, you add some more amount of, you add some more amount of water, you form liquid crystal structure 2, liquid crystal 3, liquid crystal 4, micelles, and homogeneous solution. So without your notice, you are generating such a complicated structure on your body. When you get into the bathroom, when you try to roll, wet your body, try to roll soap cake up in your body. So what happens is that there's systematic generation of, ladies and gentlemen, 4 different types of liquid crystal structure. Therefore, you are supposed to take longer period to wash your hand. Otherwise, see, this is a very important situation. So micelles are formed. Micelles are ruptured in homogeneous solution. So these homogeneous solutions are the cause for to generate, take away, destroy the surface of your COVID-19 or any virus or any bacteria. Any system, any microorganism that is enveloped in the sense that has a fatty layer outside. So if you use soap, it will destroy. Okay, so I recommend all of you. This is the reason, ladies and gentlemen. Okay, you have to allow the system to generate 4 liquid crystal structure. You can't jump. You can't be jumping from here to here. So slowly you have to allow the system to form. Everybody says you have to watch 20 seconds, but for what? It is for this reason, ladies and gentlemen. You have to allow the liquid crystal structure to form 1, 2, 3, 4 micelles and homogeneous solution. So this process you have to follow. Therefore, ladies and gentlemen, it takes time. All right. So I think this slide is very, very important. Why scientists or anybody is saying, as far as, of course, here nobody talks about liquid crystal. Now I'm talking about, because it's not common, so common. As a liquid crystal chemist, I would say that this is what is happening. Okay, everybody knows it, but nobody talks about it. Now in televisions and in news media, there are so many messages that has been wrongly given. I'm so sorry. Some of the media, they're not so prompt. Some people say don't use sanitizer. That's the wrong thing to do. Don't use what is it called alcohol-based. That's all wrong. So if you use, if you wash your hand for more than 30 seconds. Now, why I'm saying is there are demonstrations we have proved in our center that if you wash your hand more than 30 seconds, what you're trying to do is you are trying to generate these 4 structures followed by micelles and homogeneous solutions. You are very safe. This particular, anything for that matter, simple, you are cold, it's because of your hand. Okay, your hand are the culprits. So if you can wash, if you can protect your nose with a mask, not allow the, by the way, this COVID-19 is a virus. It persists. It doesn't leave. It persists. Okay, you will be inviting. It's not coming to you, your door. You are inviting, not by washing your hand. When you are, say, when a person, let's say that there's a asymptomatic person, he or she coughs or speaks, those droplets. Now I'm talking. I don't know how many droplets I'm throwing around here in this hall. So when somebody comes and touches, or the asymptomatic person who would have spoken for a long time, and they touch, the unknown person comes and touch the droplets, take it to surface, take it to mouth or nose or eye. So that's how this particular disease spreads. Okay, if you are able to wash your hand now and then, alternatively wash your hand with soap water for 30 seconds, and followed by this one, using hand sanitizer. Because if you wash your hand repeatedly with only water, you will get some kind of a numbness. In the sense, maybe you feel very irritating because all the time wetting. Instead of that, you can alternatively use sanitizer or water. Okay. Now I would like to give a beautiful demonstration that there are 2 countries in the world which are very safe. There are cases 1 or 2 here and there, Japan and Taiwan. I had the opportunity to work in Taiwan. See, these people know how to survive. Always they wear mask and they wash their hand. Always they keep sanitizer. I think all of you know, all the countries are in news, but not Taiwan, but not Japan. Because they know how to survive. Right from the beginning, I had an opportunity to visit Japan for more than 7 times, okay? Why I'm saying that, I'm not saying that, I'm keeping my modest aside and saying that every time I visited Japan, to talk to my collaborators and work with them, I stayed for more than 3 months once for a big project. Every time I see people are wearing masks, especially the old people, they wear masks, they keep sanitizer. Right from the beginning. That's why they don't have, in that country, there is no cold. No person falls sick and they cough, they will have fever. It's very amazing. Okay, this is very simple. If our citizens, say, if you go to market now, if you go outside the bank, if you go to outside your house, step out, there are people do not wear mask. Despite the fact that there is a problem, they do not wear mask. They do not follow the social distancing. What is it that we are talking about? So this is very bad situation. If that is the case, I'm sorry to say, we may enter into a big problem. Second wave may, I hope, touch wood, I think should happen. But if you don't take care of ourselves, but just the simple rule is very simple. It's extremely simple. When you step out of your house, please wear mask, maintain social distance, use sanitizer. Very simple. Even if you are at home, okay. Let's say that you go to market as a young person. You go to market. I'm especially addressing students and also my colleagues, teachers. You come to college, speak to person. You don't know whether you have come in contact with an asymptomatic person. If you are wearing a mask, and if you have a sanitizer in your pocket, nothing can portable. Let me tell you how this all these people, the caretakers, in a sense, medical staff, how they are surviving. It's very simple. They wear a very good mask, surgical mask, and sanitizer. Okay, they sanitize their hand very often. Not that they put gown or something, they will be protected. No, it's not like that. The very important aspect of anybody, any individual, is mask. Wear a proper mask. At least it should have a 2 to 3 layers. I recommend you to go up to 4 or 5 layers. Okay, the older people should have about 5 layers of cloth. Even if they are comfortable. Otherwise, 2 to 3 would be okay. But if you are very sensitive and if you are able to withstand, when you increase the layers, the inlet of oxygen is reduced drastically. So if you are able to, you are comfortable with 4 or 3 layers is fine. One can go up to 7 layers. Okay, there's nothing wrong. So what I intend to say is, drinking water is important. Sanitization is very important. Maintaining social distance, whatever government is saying. So government is saying not on its own. There is something called World Health Organization, CDC. There is a World WHO. So WHO has found this. Okay, this is the only solution. Okay, there is a scientific background. I can tell you there are more than about 200 publications span about 8 months, publishing only on COVID-19 situation. Imagine, so much of research has gone in. Now, in our center, although you are under lock, okay, everybody is sitting at home comfortably, but we scientists, most of the colleagues have come here, we have worked, we have developed sanitizers, we have developed masks, and if you go to Amazon.com, our sanitizers are there. Not sanitizers, masks. Now, our sanitizers will be coming to market very soon. Our Amazon, if you go, 3BO, Center for Nano and Soft Matter Sciences, they are very popular. Very, very popular. They're selling like hotcake. Are not able to provide. Of course, we have transferred this technology to a industry. They are making it up. Please log into Amazon. Look for Tribo. Tribo Electric means we have generated a mask. They are made up of what is known as Tribo, the material which can give Tribo electricity. I'll give you one example. You take, when you comb your hair, especially during what is called during what is it called? During this season, what is this season called? Whatever. When you try to comb your hair and try to take it near the the pieces of paper, you'll see that there's attraction. Okay, that is nothing but electrostatic force. Okay, when there is no moisture, if the weather is very dry, now we see this situation is like this. When you try to comb your hair, there is a generation of electricity. So what we use 2 layers. When you talk, there's a friction between the 2 layers, and they generate electricity. So this small amount of electricity is good enough to kill or to destroy the outer layer of virus. Well, I think so far I've been able to give you a bit of advice and talked about a bit of science, and everything has a basis. Whatsoever, liquid crystals are very important as far as our life is concerned. They form the basis of our life. If you want to be very healthy, you keep please drinking water. In essence, I intend to say that today I've been able to talk about the 4th state of matter. It exists between the, I'm talking about liquid crystal. Liquid crystal represents yet another state of matter. They are very soft and delicate states of matter. They form the basis of our life. They flow like liquids. At the same time, they show what is known as the birefringence. Thank you very much. Thank you one and all. Sorry, I've taken 30 minutes extra. I'm very sorry, extremely sorry.
It's all right, sir.
Thank you very much.
Thank you very much, sir, for your valuable information. Now it's time for interaction. Student can ask your questions and interact with the speaker one by one, or you can chat your questions and doubts in the chat box.
Let them ask straight away. They can come online. They can come online, no problem.
Yes.
Allow them.
Yes, sir. Yes. Students, you can unmute yourself and you can ask the questions directly to the speaker.
Sir,
Please.
you told whatever liquid crystal molecule you prepared is a banana shape.
Yeah.
Like that, different molecules with different shape will exhibit different property in their in the sense.
Exactly, madam. You got me. You got me right.
Yeah.
Yeah, they show different phases. Yeah.
Okay. And one more, sir. In LCD TV, we have liquid crystal function.
Yeah.
In this normal TV, actually, we can get it repaired, but LCD TV cannot be repaired. It has lifetime with respect to its function.
Hmm.
Is it with respect to the property you told as time goes on, it can turn to crystal state? Is the same or any other?
Yes, you are right, madam. As you with the time, if
Yeah.
the constituent in the LCD, the constituent is pneumatic liquid crystal. It is nothing but organic molecule in turn.
Yeah.
If the organic molecules are not prepared properly, if they are not of high quality, okay, you have German, I'm sorry, there is one country which produces such devices. I don't want to take name. There are some countries which make them very cheap. Means the cheap materials are being used. Okay, so they do not exist longer time. Now suppose that if you take Indian devices, they are high quality. German devices or US devices or Japanese devices, Korean devices, they are very strong because we make the organic molecule we use, they are very stable.
Okay, thank you, sir. Very nice explanation. I think our students enjoy.
But I am amazed to see not a single student is asking question.
Maybe they'll take some time and ask. Let us see, sir.
Yeah, I can wait.
Yeah, few minutes time will give. Yes, students, if you have any doubt, you can just ask. And one more thing, sir. Normally, when we teach our students, we say solid, liquid, and gaseous, 3 states, and plasma also nowadays we introduce. Liquid crystal we never mention unless it is mentioned as a separate topic actually.
That's an unfortunate thing.
Yeah, that's what.
That's quite unfortunate. See, if you know about, let me tell you, I didn't mention because I'm running out of time. I have run out of time.
Yeah.
Actually, what we teach is 18-hour syllabus. This is 18-hour syllabus in our center.
Okay. Sir.
If I teach it properly, it can be 18-hour syllabus. Okay. Each and every aspect of if you touch. Okay. Let me put it this way, madam.
Yeah.
The person who has a habit of drinking water, they remain very healthy.
Okay, sir.
Generally, this is because you are basically putting your plasma membrane back into its liquid crystal structure.
Okay, sir.
Otherwise, what happens most of the time, especially ladies, I know me, including my mother or my wife or my daughter, they'll be running around to finish their work, whole things, and then job at your workplace. So when you get busy, you tend to forget drinking water.
Yes, sir.
That is leading to say, I'm very sorry, breast cancer.
Okay, sir.
So, I mean, these are a very sensitive topic. I mean, if only one thing I would rather tell everybody that whatsoever, please make a habit of drinking water.
Okay, sir.
Yeah, I mean, say warm water. Warm water is always better. Cold water should never drink, never drink, never drink.
Okay, sir.
Should never drink cold water. There is adverse effect.
Okay, sir.
It's scientifically proved.
Yes, sir. Yes, sir. So if you're exposed like this to some research areas, definitely in our topic, maybe in physics, chemistry, we introduce like this liquid crystal is there, not there for exam, but yeah, like that.
No. If it were to be live, let me tell you, if it were to be live demonstration, whatever I showed in the birefringence or fluidity, if it were to be live, I mean, you know, I think you attended my lecture. Who attended?
Yes, sir.
I showed live, isn't it?
Yes, sir.
So that was enjoyable. See, now my presentation, they do not match. Every time I keep changing. In a sense, it depends on how, see, the way I talk to you is different the way I'm talking to students.
Yeah.
So it all depends on who is the audience. So in essence, the basic information is given, it will be the same.
Yeah.
Fine.
Sir, when everything comes to normalcy, sir, once we'll arrange for that live this thing, sir.
Sure.
Yes.
And I invite you students to come and visit our center.
Yes.
And whatever is spoken, double refraction. And when I take a pencil, put on the top of, when I take a crystal and I have a pencil, put on the top of the pencil, we'll be able to say 2 images, birefringence can be shown here. All the experiments can be shown here. Whatever I spoke, everything can be demonstrated here.
Yes, sir, definitely we'll bring our students once when everything becomes normal, sir. Definitely we'll visit your center.
Yeah, how many students attended this talk?
Online at home they are attending, and YouTube live also we are relying.
Okay, I hope it was useful. Okay.
Yeah, definitely, sir. Definitely.
Any student? I want at least one student to question me, trap me.
Yes, any student can ask any question.
I don't know whether sleeping.
No, we have very good students also.
Hey, one person. I have a lot of regards, respect for ME students.
Yeah, definitely we have a very good crowd. Let us see, sir. Few minutes, let us wait and.
But I should not fall asleep.
No, it will not happen. Yes, Kishan, I can ask the question. He has mentioned, Kishan ji, he has read some article about you, it seems.
My papers.
Yes, some graphene.
Okay.
He's sending the chart messages, sir.
Okay, please ask. No, they can unmute.
Yes, sir. They have an option to unmute themselves.
Students, you can unmute yourself and ask any doubt if you have or any clarification. Don't hesitate. If it is not relating to this topic also.
I understand that they are not understood, or I spoke in such a way that they did not understand.
They are able to understand, definitely. Yes, students, Akash. Sir, we'll pass on your email ID. If they have any question, they will.
Please. I think there will be some technical issues there.
Yes, slowly they may ask if they have any.
All right. I hope this lecture was of some.
Yes, Sunil sir, in chat box, Kishan ji asked some question. Just read out.
Wait a second, ma'am.
Yeah, Kishan ji, he asked some question in chat box. Just read out to sir.
Can you get that chat box, sir? I think I'm not getting it.
Yeah, 1 minute, sir. I'll tell you.
Sir, please check your chat box.
I have asked sir in the chat box he told.
I don't receive any chat. Please, sir, check it.
Would it be possible if I record it on YouTube? Would it be
Yes.
possible to send recorded this thing to me?
Yes, sir. We'll send. We'll give the link, sir. We'll send it.
But it is there on YouTube now.
Yes, sir.
Yes, sir. Yes, sir.
Okay, put it on YouTube.
Yes, sir. Yes, sir.
Fine. Okay.
Sir, there is a question
Hmm.
by one of the student. I read an article that there is a new research about the twisted graphene system hosting chargeless valley current. Could you please help me to understand the topic more clearly, sir?
Okay, I think it's a quite a interesting question. I would rather recommend the student to write to me on email. Okay.
Okay.
Please ask him to interact with me through email. Okay.
Okay.
Graphene itself is a big, vast subject. Okay, it's not so easy. I mean, you know, the stalwarts, Professor C.N.R. Rao and other many eminent scientists are working.
Okay.
Although I don't have an authority, but I have worked on it.
Okay. We'll share your, if your permission, sir, we'll share your email.
Yeah.
They will ask question on that. That one will ask the student.
Right. No, you do one thing. Otherwise, collectively, collect the questions, post it to my email. Collect it in a list, make a list, and then send it to me. I shall answer them.
Okay, sir. We'll do that one, sir.
Thank you very much. Shall I take leave?
One minute, sir. Vote of thanks, sir. Formal vote of thanks. 1 minute, sir.
All right.
Okay, sir.
Thank you, sir, for clarifying the doubts.
Yeah.
Now, may I call Srimati Soumya P, lecturer from Department of Physics, to propose vote of thanks.
Feeling gratitude and not expressing it is like wrapping a present and not giving it. Gratitude makes sense of your past, brings peace for today, and creates a vision for tomorrow. Melody Big Day. Good afternoon to everyone present in this meeting. Myself, Soumya P, lecturer, Department of Physics. Honorable Chief Guest, Dr. C.V. Yelamagad, Principal, Vice Principal, teaching and non-teaching staff, my dear students, and all the participants. It's my privilege to propose the vote of thanks and acknowledge the contribution of those who work to make this webinar successful. On behalf of the entire fraternity of MES Kichora Kendra PU College, first of all, I extend my gratitude to our chief guest, Dr. C.V. Yelamagad, who spared his valuable time to share his knowledge about unique state of matter, that is liquid crystal, in detail with our students. Thank you, sir.
Thank you very much. Thank you.
I'm sure this session is going to be very useful for our young minds and make them understand the concepts better. I would like to thank our beloved principal, Srimati Sunita R, and Vice Principal, Srimati Shantala HK, for their continuous support and guidance. Thank you, ma'am. My sincere gratitude to the teaching and non-teaching staff for their cooperation and support. I would like to extend my gratitude to our technical team for making this event hassle-free. Last but not the least, thanks to our students and all the participants who have been an integral part of this meeting. Thank you, one and all. Thank you, sir.
Yeah, what is the number? How many students attended?
Sunil, sir, just tell. In YouTube, how many? Sunil, sir?
Sir, as of now, there are only 28 participants are there in the meeting, but in YouTube, they are watching, sir.
But how many? I want the number because I have to note down here. I have to write here in ledger.
Yeah, in the beginning, there are 60 participants, sir.
Okay.
Directly in Zoom. In YouTube, we have to see, sir, how many are there. Sunil, is it possible to see and tell?
Yes, may I give the details after this session?
Yeah, please. Please pass on a message to me. I'll put in. Generally, we have to report.
Yes, sir. We'll just send through the mail, sir. Is it okay?
All right. Thank you. Thank you. See you all. Thank you once again for giving me this wonderful opportunity. I hope I served the purpose. Thank you.
Yeah, definitely, sir. Thank you.
Thank you very much.
For thanking each and everyone for the success of this webinar.